Good afternoon, everyone. Thank you for joining us on our next installment of Optimizing Costs on AWS. My name is Dennis Bruce. I'm a partner here at the 3XM Group, and we are joined today by Alexis Cuadrado and Jorge Atala. Alexis is the lead on the cloud practice lead, and Jorge is the director of engineering. And as I've mentioned, we'll be talking about optimizing costs on AWS. Today is a relatively short webinar, 30 to 40 minutes, and we are going to kick it off with Alexis. And as we go along, any questions you have, please send them along in the chat. We'll address them at the end, and we'll hopefully get everybody's questions answered within the 40-minute time limit. So I'd like to tell you a little bit about 3XM Group, and we specialize in different solutions, including software development, cloud, DevOps security, and data engineering. We have a proactive and innovative approach to engagements, having successfully delivered more than 100 projects to clients in the US, Canada, and Latin America. So once again, today's topic is optimizing costs on AWS, where we've had a great deal of experience. And leading that conversation today will be Alexis Cuadrado. I'd like to introduce him right now. He'll be taking over. Alexis will provide detailed agenda and the specific topics throughout. And as I mentioned, we'll be collecting any questions you may have, which please feel free to send them through the chat window, and we'll address them at the end of the webinar. So let's also mention before we start that we will be offering to all participants a free 1-hour consultation for any AWS issues that you have related to cost optimization, or maybe other issues such as security, scalability, anything that you may have issues with. Please do use the form that we'll be providing a link to schedule that free 1-hour consultation, and we'll make sure that we get that on the calendar for you. We'll conduct a checklist review of your current architecture with you and your IT team, and after the consultation, we'll provide you a report with relevant findings and our recommendations. So that's free for all of our webinar participants today. And once again, we'll get it kicked off here with Alexis Cuadrado. Alexis, please take off.
Thank you, Dennis, for that kind introduction. So hello, everyone, and welcome. Thank you all for taking the time to join us today for the second edition of our webinar titled Optimizing Costs on AWS, where I'll be discussing precisely the often neglected subject of cost optimization in the cloud. So our agenda for today looks like this. First of all, we're going to start off by talking a little bit about cloud economics. Then we're going to provide some definitions for cost optimization and related concepts. And eventually we'll arrive at the core topic for our discussion today, which is the 3 levers for cost optimization, 3 different ways in which you can optimize cost on AWS, that is, optimize usage, optimize the rates you're getting, and optimize your operations in the cloud. Then we're going to briefly touch on some cost management topics and AWS tools that you can use for cost management on AWS. And finally, we'll wrap up with some advice and key takeaways for today's session. First of all, there's 4 ideas about cost optimization I want to plant in your head and hopefully grow throughout the rest of this presentation. So first of all, cost optimization is not cost cutting. It's not something you do only when you're on a tight budget. Cost optimization is rather an ongoing effort, right? It's not some one-off activity you carry out at some point in your cloud journey, but rather an ongoing incremental process that yields benefits over time. Third, cost optimization is about business value. So while avoiding costs is an important part of it, the end goal behind cloud cost optimization is to make money, not to save money. So cost optimization seeks to deliver the highest business value at the lowest cost, so you can free up capital for other business differentiating activities. And last, cost optimization, as you'll see throughout this session, is key to cloud success. So on to cloud economics. I want to talk a little bit about economics of the cloud so as to put cost optimization into perspective. The advantages offered by the cloud are best understood when comparing it to the traditional IT/data center model. While the word traditional suggests past tense, many companies around the world still have their infrastructure on premises and thus employ the traditional IT model today. Now, while one might still find valid reasons for companies to keep their own IT infrastructure, this model has some well-known problems. So for starters, setting up an on-site data center requires large upfront capital investments. Acquiring new hardware can take weeks or even months, as the decision to buy typically must go through multiple layers of approval. Data centers also involve a lot of IT chores, such as installing physical servers, patching operating systems, replacing faulty hard drives, as well as other time-consuming management tasks that don't differentiate the business. Capacity planning is usually a major challenge in traditional IT because it requires predicting technology needs maybe months in advance, right? So it's very difficult to do that accurately, which is why companies end up provisioning extra capacity to avoid potential service outages, resulting in a lot of wasted resources on average. The cloud presents an entirely different situation. It does not require long-term contracts or spend commitments. You pay for what you use. Cloud infrastructure is provided self-service and on-demand, meaning that with just a few mouse clicks or terminal commands, engineers can provision any computing resources they want, even in large quantities. This takes seconds, minutes at most, allowing teams to move faster. Speaking of moving faster, it is also important to know that given that the cloud removes the need for many of the management tasks performed in the data center world, IT staff can spend more time on strategic differentiating work, like getting the latest updates and features out to customers. This also frees up capital for other things that can help organizations grow faster, such as expanding to new geographies. Lastly, organizations can take advantage of the cloud's elasticity to provision the capacity they need and nothing more. So this means that during periods of low usage, they can use fewer resources and thus incur fewer costs, whereas during periods of high demand, the system can be configured to scale to achieve the required performance. So by closely matching supply and demand in this way, the inherent waste in the traditional data center model is eliminated altogether. So going back to the undifferentiated heavy lifting, so the cloud takes away a big piece of it, right? So things like procuring physical servers, setting up racks, structured cabling. The cloud eliminates all that, plus overhead costs such as power, cooling, and security. Also rent on real estate costs, things like property taxes, shared services staff, building depreciation, so on and so forth. So overall, it's easy to see how the cloud helps reduce total cost of ownership, or TCO. But for all its power, the cloud comes with challenges of its own. Some of the difficulties associated with cloud computing are: costs are easy to incur. So the cloud is on demand and self-service, and charges begin to accrue as soon as resources are provisioned, which can be done either directly by engineers or by automatic deployment processes. Billing data is complex. Cloud billing data is complex because cloud usage typically incurs thousands, if not millions, of individual product charges, most of which are billed by the minute or even by the second. So making sense of all this data requires deep understanding of cloud services and infrastructure. Also, organizations lack cloud expertise. Solid knowledge of cloud services and infrastructure is required to run workloads cost efficiently, and this type of knowledge is not easy to come by. Also, cloud evolves quickly. As more and more workloads are placed in the cloud technologies continue to advance, and cloud service offerings proliferate. So it's hard to keep up, even for specialists. And last but not least, forecasting is difficult. So the on-demand and elastic nature of the cloud makes forecasting and budgeting an organization's cloud spend particularly difficult. So without the right mindset and practices to address all these difficulties, cloud costs can quickly spiral out of control and become steep enough to undermine the economic benefits of the cloud. So that's why organizations must develop a cost-conscious culture that promotes visibility, transparency, and accountability to manage and optimize costs efficiently, while also promoting business agility. This is what we mean by lean cost culture. So a lean cost culture aligns to some of the following values or principles. First of all, decisions are driven by cloud value, not cloud cost, and I'll talk about that in a second. Second, cost is everyone's responsibility. Everybody in the organization takes ownership of and is accountable for their cloud usage. Third, cost data must be accessible, transparent, and opportune. That means that it's available and presented conveniently to those who need it exactly when they need it. And last, cost optimization is considered in planning, design, and development. So I want to expand a little bit about what I mean by decisions are driven by cloud value, not cloud cost. So it's important for organizations to understand not just what they're spending in the cloud, but the value they're getting in return. Consider things like time to market, speed of innovation, increased software quality, new geographic regions, more customers, happier customers. A bigger bill at the end of the month does not necessarily mean there's a problem if you're expanding your business, if you're increasing your margins, or just enhancing your capabilities. So the key takeaway from all of this is that savings is not always the final goal. Instead of asking themselves, how can we reduce our cloud costs, organizations should think, how should we spend our money in the cloud to bring the biggest value to our business? So what is cost optimization? So at the beginning of the presentation, I said 4 things about cost optimization, but I didn't really give a definition. So here it goes. Cost optimization is a continual process of refinement and improvement of a system over its life cycle so that it achieves business outcomes while minimizing costs. So I like this definition because it's succinct and emphasizes 2 aspects of cost optimization that are often omitted. Its focus on business outcomes or business value, and the fact that it is a continuous process. So cost optimization is one of the 5 pillars of the AWS well-architected framework, which is a set of guidelines to design, build, and operate systems on AWS based on best practices. The well-architected framework helps you understand if a specific architecture gathers all of the qualities one would expect from a modern cloud-based system, and how to achieve such qualities if deviations are detected. So the fact that cost optimization is one of the pillars of the well-architected framework highlights the importance of considering costs when architecting for the cloud. Now, cost optimization, as I said, plays a key role in realizing the cloud's financial benefits. Take a look at the following example from a case study by Gartner. This is cost data from a real company which migrated 2,500 virtual machines from an on-premises data center to AWS. If you look at the chart, you'll notice that cloud costs soar throughout the migration phase to the point of becoming higher than the original on-premise cost. However, cloud costs begin to drop as soon as the organization gradually learns how to apply cost optimization best practices, like right-sizing, scheduling, and instance reservations. Thanks to all of this, they eventually managed to reduce their TCO by 55%. So the whole process took 3 years. This case illustrates 3 important things. First of all, how much an organization can overspend by not architecting for cost efficiency. Second, how cost optimization as a continual process incrementally delivers benefits over time. And third, the importance of cost optimization for effectively optimizing TCO in the cloud. So in the last example, we saw how a company migrated to AWS following a lift and shift approach, and then gradually reduced its spend by right-sizing and scheduling instances, as well as purchasing reservations. But that's not quite all there is to cost optimization. So ultimately, the goal is to architect solutions for the cloud that take advantage of things like auto-scaling, managed services, distributed edge caches, serverless functions, containers, not only to drive further cost reductions, but also to be able to innovate faster and free up time and capital for value-adding activities. And the good thing is, if you have a greenfield project in your hands and are not tied to an on-premises legacy architecture, you can design your workloads to take full advantage of the cloud from the very beginning. So breaking down cloud costs. The thing about cost optimization is that all too often organizations focus exclusively on the cost of infrastructure itself. But the biggest cost in software is usually the people. So you can think of your total cost of ownership in the cloud like this. It's roughly equal to the money you pay the cloud provider plus your operational costs. There might be other factors such as software licenses and third-party service fees. So that's why I'm saying roughly equal. But usually the main two components of your cloud costs are going to be these two. Now, cloud bills typically show thousands and thousands of charges, which are derived from a complex relationship among several variables, things like network throughput, data ingestion, storage, processing units, and so on. So regardless of the true variables at play, your cloud bill amount will always be some function of your cloud usage and the rates offered by the cloud provider. Where I'm going with this is that there are truly three things you can optimize in order to minimize your overall cloud costs. And these are, first and foremost, your cloud usage. We've already talked about how cloud usage and cost are intertwined, right? Second, the rates you pay for your cloud usage. Cloud providers, with AWS being no exception, offer different purchasing options, as well as committed use discounts and volume discounts, for example, which allow customers to get significantly lower rates. And lastly, your operational costs. So improving your operational efficiency not only yields significant savings, but also, as we've seen, allows your people to focus more on your business and not so much on IT management chores. And thus, we get the three levers for cost optimization I mentioned at the beginning of this talk. So we can optimize usage, we can optimize the rates we're getting, and we can optimize our operations. So next, we're going to see different approaches for cost optimization on AWS, each of which pulls on one of these levers, sometimes even more than one at the same time. So let's start with some strategies for avoiding unnecessary usage. Note that generally speaking, the applicability and potential impact on savings of each of the strategies we're going to see is relative to the workload and situation at hand. That being said, it's pretty common to find unused resources in AWS accounts. So we've already seen how cloud costs, in this case AWS costs, are strictly tied to usage. So it goes without saying that we should be careful to provision only the resources we need for however long we need them, and then turn them off when we're done, right? So, well, you'll be surprised by how much garbage one can find lying around in an AWS account. Things like idle EC2 instances, stale EBS snapshots, unattached elastic IP addresses, load balancers, NAT gateways, just to name a few of the most common. So all these things incur costs, and they won't cease to do so until you delete them. So you might think, well, if I leave this instance on, it really isn't a big deal. So one small EC2 instance might not be a problem, but if your whole cloud team takes the same carefree approach, in time you will have maybe 5 or 10 unused instances plus their EBS volumes plus load balancers and so on. If you don't get into the habit of terminating resources when you don't need them anymore, they'll begin to pile up and eventually become a considerable part of your bill. Now, unused resources on AWS are typically a byproduct of POCs, training labs, and dev environments, but they're also a byproduct of evolving production workloads. So your architecture is likely to change over time. You will need to migrate to newer EC2 instance generations. Your engineers will move stuff around, probably switch from one service to another, and forget, because quite often they forget, to clean up after themselves. So if you don't need it, delete it and get into the habit of doing just that. Next, right sizing is probably one of the most effective ways to control cloud costs. It consists in analyzing performance and usage patterns, and then resizing resources that are over-provisioned for the workload at hand. So because your resource needs are always changing, right-sizing must also become an ongoing process. Typically, when we talk about right-sizing, we refer to EC2 instances, but right-sizing is something that can and should be done for any resource for which you allocate capacity in the form of CPU, RAM, storage, network throughput, and so on. Consider things like RDS instances, Redshift clusters, Fargate tasks, etc. So in any case, decisions for right sizing must be based on recent performance data observed over a period of at least a month. If you analyze shorter periods, like 2 weeks, for example, you might miss important load patterns and end up under provisioning your resources in some cases. The thing is, one can't solely rely on right sizing to match capacity to demand. The reason being that for most workloads, demand changes over time. So in order to be able to closely match resources with demand at all times and avoid overpaying, one must also leverage the cloud's elasticity. Now, there are two types of elasticity that can be introduced to a cloud-based solution. One is load-based, also called volume-based elasticity, and the other one is time-based elasticity. With load-based elasticity, resources can be scaled automatically to match fluctuating demand. So the most famous tool for accomplishing this in AWS is EC2 autoscaling, which allows you to automatically increase the number of EC2 instances during demand spikes, and conversely reduce the number of instances during lulls to reduce costs. There's also autoscaling for other services such as CCS, DynamoDB, and Aurora. Now, autoscaling is well suited for workloads that experience variability in usage, which is, and I'm talking about variability that is more or less unpredictable. For workloads that have a consistent usage pattern, one can rely on time-based elasticity instead. For example, a lot of applications are only used during business hours and thus can be stopped or turned off outside these hours and during weekends. For example, servers used for batch processing in nightly jobs can be turned on only when they're needed, right? So although it's possible to manually shut down and turn on resources, this is impractical and time-consuming, particularly at larger scale. So take advantage of time-based elasticity and automate. You can use, for example, the AWS Instance Scheduler solution for EC2 and turn off instances outside business hours to reduce your costs by roughly 70%, as in the example shown on the right. You can also use AWS CloudFormation to automatically provision and decommission entire environments as you need them. You can also build your own solutions using things like CloudWatch and Lambda. The key question that should be answered before choosing between load-based and time-based elasticity is how consistent and predictable is the demand. So right, sometimes you may wind up using a combination of both forms of elasticity. Now, if you're storing data in the order of terabytes on AWS, storage will definitely make up a big part of your AWS build. So it's important to optimize for storage, right? Consider S3 for object storage, for example. S3 provides different storage classes or tiers for data with different access patterns, each with its own rates, right? Each of these tiers has its own rates. So make sure you understand the different tiers and store your data in the correct one, depending on whether it's accessed multiple times per day, once a month, or once a year. So these different access patterns will determine, or should determine, which tier you're storing your data in. So if you're not sure, you can use intelligent tiering, which analyzes access patterns for you and transitions your objects to the most suitable storage class. In the case of elastic block storage, or EBS, a typical mistake is leaving unattached volumes behind when terminating EC2 instances. So make sure to identify and delete those. Also, don't provision more storage capacity than you need. You'll still be paying for it whether you actually use it or not. Lastly, make sure that you're deleting your old EBS snapshots, either via lifecycle policies or some other automated process, but do automate the snapshot rotation process. Now, obviously, there are other approaches to reduce usage on AWS or to optimize for usage. Unfortunately, we don't have time to cover all of them. So let's move on to how we can optimize our rates on AWS. The first step towards implementing successful cost optimization strategies that pull on the rate optimization lever on AWS is getting familiar with AWS's pricing philosophy. So in AWS, you pay as you go. So you replace large upfront capital investments with low variable costs and pay only for what you use. No minimum commitments or long-term contracts required. So, but you can commit to a certain amount of usage by reserving, and you can pay less by reserving. So for certain products like EC2 and RDS instances, you can invest in reserved capacity. This way, you can get a significantly discounted hourly rate, which can result in overall savings as high as 70%, 72% in some cases. So one other way you can save money is by using more. Well, obviously that's not actually a choice. At a certain scale, you will get what is called volume discounts. So for example, for storage and data transfer, pricing is tiered. The more you use, the less you pay per gigabyte. And you can also get volume discounts for compute instance reservations, for example. Then if you have a high volume project in your hands or some unusual requirements, you can always talk to AWS and get custom pricing. So you can see if they can get you a better deal. And lastly, you can pay even less as AWS grows. This means that you can benefit directly from AWS's economies of scale, which eventually allow them to pass savings back to the customer in the form of price reduction. So this virtuous cycle is depicted by the famous Amazon flywheel shown on the right-hand side. Now, note that prices vary by region, so it's important to realize this when architecting solutions for the cloud. So the AWS cloud infrastructure is built around regions, as you probably already know. Each AWS region operates within local market conditions, and resource pricing can be different in each region. Now, sometimes due to latency or to regulatory reasons, you might be forced to choose a particular region. For global audiences, you might even need to use multiple regions to meet your needs. But within these constraints, you always want to select the geographic region or regions that minimize your costs. Note that not all US regions cost the same. California, for example, may be up to 21% more expensive than Virginia or Oregon for some workloads. Now, while Virginia is across the country, latency between Oregon and California is around 30 milliseconds. So although you and your users might be closer to California, choosing Oregon might still be a better alternative if your application can tolerate the extra latency of 30 milliseconds. Now, purchasing options. So for some services, AWS offers a number of purchasing options or pricing models, allowing you to choose the one that suits your business requirements in the most cost-effective way. The purchasing options that are available depend on the service we're talking about, but broadly speaking, these can be categorized as on-demand. This is the purchasing option by default. So when you use services such as EC2 or DynamoDB on demand, you pay a flat hourly rate with no long-term commitments. Then you have reserved. By committing to a certain amount of to use a certain amount of resources for a period of time, you can drastically reduce your AWS costs. I'm talking about up to 72% over on-demand rates for the case of EC2, for example. So the reasoning behind reserved purchasing options is very simple. You ensured continued business for AWS for 1 or 3 years, and in return, you are rewarded lower rates. Then we have spot. Now, if savings is your goal, you should definitely look at spot. Essentially, spot is excess capacity that Amazon offers at very low prices compared to on-demand, up to 90% smaller in the case of EC2. As of today, the spot purchasing option is only available for EC2 and Fargate. Now, dedicated, we're not going to cover in this session, but going back to reserved, by far the most comprehensive reservation model offered by AWS is that of EC2. And not surprisingly, it's also the most widely used. Now, as much as I would love to talk about EC2 reserved instances, I'm kidding, I would not. There's simply not enough time to go over them today. This is because it's a really complex pricing model, but luckily, there's a new neighbor on the block. And it might have just come to solve that exact problem. I'm talking about savings plans, which were announced back in November 2019. So savings plans are basically a flexible form of committed use discounts that allow you to save money in exchange for making a commitment to a consistent amount of usage, which is measured in dollars per hour. Now, savings plans come in two flavors. One is EC2 instance savings plans, which provide the largest discount, up to 72%. EC2 instance savings plans cover usage of different sizes of the same instance type. For example, C5.2x large or C5.large instances are within the same family, which is C5, within a specific AWS region. But they also let you switch platform from Windows to Linux, for example, and continue to benefit without having to make any changes to the plan. So they give you more flexibility than standard reserved instances in that sense. Now, the other flavor of savings plans, and also the most interesting one, is compute savings plans. So compute savings plans have two distinct features that make them unique. They are global, which means they automatically reduce your usage costs across any AWS region, and they apply to Fargate and Lambda usage as well as to EC2 instance usage. So this is huge. Given that workloads are not always confined to a single region and certainly are not always purely EC2 based or purely serverless, but rather a combination of both, savings plans offer a great deal, right? So due to their greater flexibility, the savings potential of compute savings plans is a bit lower than that of EC2 instance savings plans, but they also incur lower risk, right? So you can get up to 66% in savings with compute savings plans. It is also important to note that savings plans, regardless of their flavor, apply to any on-demand usage that is not covered by reserved instances, which are applied first, right? So you can still use reserved instances in combination with savings plans and benefit from the two, but Amazon is pushing customers to move to savings plans as they can. Now, the spot pricing model, as I said before, is really, really interesting because it yields huge savings, up to 90% in the case of EC2. So how is this possible? Well, spot instances are basically excess capacity that AWS offers at discount prices. These prices vary based on supply and demand trends, right? So the catch is that eventually AWS will reclaim that capacity and give it to a customer who's willing to pay more than you, or who's willing to pay the on-demand price. So your workloads will be interrupted with a 2-minute notice, and you will need to have engineered your solution so that these interruptions are handled gracefully. For these reasons, not all applications are suitable for the spot model, but things like stateless web services, batch processing, parallel computing certainly are. So I'd like to encourage you to go ahead and experiment with Spot if you haven't already started doing so. AWS has made using Spot increasingly easier over the years. There's also a lot of community resources out there to help you get started. Now, that's all about the rate reduction strategies we're going to cover today. So let's move on to optimizing operations. Now, AWS managed services remove the burden of the undifferentiated heavy lifting we've been talking about, the undifferentiated heavy lifting required to maintain a service, which also, and by removing that, managed services allow your people to focus on innovating rather than keeping the lights on, right? So they let you reduce much of your administrative and operational overhead, freeing up time and money to work on things that truly bring value to your business. And also note that because managed services operate at cloud scale, they can offer lower cost per transaction or services sometimes. So AWS provides managed services for databases such as RDS and DynamoDB. Uh, also, it also provides application level services such as simple queue service or SQS, simple notification service or SNS, and simple email service, right? So these very services remove the need for you to manage virtual servers for code execution, queuing services, and message delivery, for example. So use managed services to reduce the cost of managing infrastructure. But consider also the time savings that will allow your teams to focus on innovating, retiring technical debt, and delivering new features. Now, you probably already are familiar with the concept of containers. Essentially, containers package an application and all its runtime dependencies into a small deployable unit that can run virtually anywhere. Containers consume much fewer resources than VM or instance-based environments because they don't include operating system images. So this helps achieve higher computational density and thus reduce unnecessary usage. So this smaller compute footprint means lower overall cost, right? But also consider what this means for your operations. Containers can greatly reduce the number of virtual machines you need to spin up and manage. Also, containers hide away the complexities of the applications they encapsulate, allowing you to treat them all the same regardless of the underlying technology and dependencies. You can then build an operations model where the only type of artifact you need to manage is the container image. And you can thus forget about tarballs, binaries, jars, WAR files, and so on. So having a consistent operation model like this allows for greater operational efficiency. Now, containers need to be orchestrated, and for that you have two options on AWS. One is the Elastic Container Service, or ECS, which is the vendor lock-in alternative, if you will. And the other one is the Elastic Kubernetes Service, or EKS, which is a managed service for the Kubernetes control plane. You can always host another solution on EC2, such as Kops or Docker Swarm, for example. Moreover, your containers need to run somewhere, regardless of the orchestration platform you choose. In AWS, it means that you have to run them either on EC2 or on Fargate. Consider using Fargate when possible to remove the need for managing servers, in which case you'll be forced to use either ECS or EKS since there is yet no Fargate support for non-native orchestration solutions. But do experiment with Fargate. It's the serverless offering for containers. It takes away a lot of a great deal of burden by removing the need to manage EC2 instances. Now, speaking about serverless offerings, so serverless architectures are the ones that exploit the advantages of the cloud computing delivery model the most. We have been talking all along about being lean, about reducing waste, about eliminating the undifferentiated heavy lifting altogether. As of today, serverless represents the cloud's best effort in that direction, right? So with serverless, you don't have to worry about provisioning, scaling, availability, fault tolerance. You don't have to worry about infrastructure maintenance. You can then devote more time and resources to what matters most, your business logic and the user experience you're building. So go ahead and try to leverage serverless offerings as much as possible. Services like Lambda for serverless functions, API Gateway, SNS, SQS, Fargate, just to name a few. If you have a new development project in your hands, serverless is a no-brainer. Naturally, re-architecting existing applications and making them serverless takes a lot of engineering effort. So consider that effort versus the added value from going serverless before making a decision, right? Now, managing infrastructure as code. So manual approaches to managing infrastructure are slow, error-prone, and make it really difficult to track changes over time. In contrast, by managing infrastructure as code, you can provision entire environments in minutes. you can reuse the same code and effortlessly replicate your infrastructure. By forcing, I don't want to say forcing, but by employing a procedure that relies on managing infrastructure as code, you can avoid configuration drift, right? By making sure that all the changes to your configuration are kept in the code. And then you can minimize risk associated with human error. This brings increased confidence and predictability. Now, this all helps, build an efficient operations model, right? And there are some lots of tools in the ecosystem that help you manage infrastructure as code. For example, Terraform, which is the one we prefer here at 3XM, but there's also AWS CloudFormation, which is the native infrastructure as code solution in AWS, and it's also used by many companies. There's also the AWS Cloud Development Kit, or CDK, which allow you to write infrastructure code in your in languages that might be already well known by your team, such as Python, JavaScript, Golang, and so on. So regardless of the tool you choose, and there are better tools or tools that are suited for particular use cases that are better than others, regardless of the tools you choose, please do manage your infrastructure as code. Now, to wrap up this section, I want to highlight the importance of automation in general. So any activity or process that doesn't differentiate the business and your engineers spend significant time on should be automated. Things like software builds and deployments. Think about continuous integration, continuous delivery, continuous deployment, infrastructure provisioning and configuration, server hardening, data backups, and more. So not only automating all these processes yields savings over time, it also frees up time and capital for other things that are that truly benefit your business, right? Focusing on building new applications, new features, and innovating, right? Things we've been talking about throughout this presentation. So cost management goes hand in hand, or rather enables exercising cost optimization in the cloud. Now, sadly, we don't have enough time to go over cost management in depth, but at least I want to give you a quick overview of two important pillars of cost management. One of them is cost visibility. This webinar has been all about cost optimization, but there's a phrase, and I believe it's originally attributed to Peter Drucker, I'm not sure about this, which goes, if you can't measure it, you can't improve it. So, cost optimization is no exception to this fact. So you need to measure and monitor your costs and do so constantly. Luckily, there are AWS native tools with which you can analyze spend and usage data, estimate future AWS cost and usage, receive notifications when you exceed spend thresholds, and so on. There are more tools, but take note of the following three. Now, AWS Cost Explorer is a simple report generator that lets you visualize your costs and your usage over time. I recommend starting here. With Cost Explorer, you can analyze your cost data at a high level. For example, you can check your total costs and usage across all of your AWS accounts. And you can dive deeper into the data by breaking down costs by services or by tags, by regions, and different criteria, right? Now, for truly granular cost analysis, the AWS Cost Explorer falls short. That's where AWS cost and usage reports come in, right? So these reports contain the most comprehensive set of cost and usage data available. A typical practice is to configure to set up exporting of the cost and usage reports to S3, and then tie in Amazon's analytics tools such as Athena, or maybe third-party analytics tools. And then finally, we have AWS budgets, which allow you to define precisely that. Budgets for your projects, for your teams, and keep track of those budgets and receive notifications or alerts when the certain thresholds are exceeded. So go ahead and take a look at these 3 tools and explore other ones if you will, and remember that if you can't measure something, you can't really improve it. And the other pillar of cost management I want to briefly touch on today is cost allocation or cost attribution. So cost allocation is about understanding who owns resources and thus who is responsible for incurring cloud costs. It's about overlaying information that's relevant to the business on top of cloud resources in order to be able to assign cost to systems, revenue streams, or parts of the company, such as departments, business units, products, or internal teams. Now, to properly allocate AWS costs, consider using tagging and account structuring via AWS organizations. Either one of these or a combination of the two will provide the cost attribution capabilities required for your business. And a combination of both is typically what we see in the companies we help manage their AWS environments. And a tip: do implement and a tagging standard across your organization, right? So having tag consistency is key to not only for automation processes, but also to be able to analyze costs accurately. Now, some final advice before we leave on cost optimization. I have 2 important pieces of advice for you. The first is to start early. So in my experience, companies begin to care about cloud costs once they cross some arbitrary threshold, which draws the executive's attention, and not in a good way, right? So for some companies, that may be a few $1,000s a month. For others, it may be a few $100,000 or even a few million. It doesn't matter. What matters is that it's very difficult to tame cloud costs once you hit scale, right? It's even more difficult to tame cloud costs if you haven't yet instilled a lean cost culture in your organization and enabled the basic mechanisms for cost management. So it's never too late to get started with cost optimization and do so effectively. But if you don't start early, things will get very complicated at scale, right? So creating a cost-conscious culture takes a lot of time and effort. The sooner you start, the earlier you will reap the benefits of the cloud. And my second advice for you is take baby steps. I don't know of any organization that has implemented efficient cost management practices overnight. So start off by having one individual devote a few hours per week to understanding the cloud bill and learning the basics of cloud cost management. Over time, start defining and evangelizing basic cost governance and optimization best practices. Eventually, you will have a small team dedicated to cloud costs, whose members define custom metrics, develop advanced reporting methodologies, and create and enforce cost allocation strategies. As your business grows and your financial needs become more and more complex, the team dedicated to cloud costs can eventually become larger and dedicate full time to supporting cost management and optimization across your organization by continuously revising policies, processes, and tools. And of course, educating your staff. So key takeaways for this session. First of all, as we saw in the first section, the cloud helps reduce TCO, but for that, cost optimization plays a key role. So, and cost optimization is a continuous and incremental process, not some one-off activity. When you address cost optimizations, decisions should be based on business value rather than costs. And you can pull on 3 levers to optimize your costs in the cloud. You can reduce your usage and get lower rates to optimize your cloud spend, but don't forget about your operations. Optimize your operations and free up time and capital for business differentiating endeavors. And last, start early, right? The earlier you start, the sooner you will reap the benefits of the cloud, the more headaches you will save yourself. So start early and gradually build a cost-conscious culture in your organization. So that would be all for today. Thank you for taking the time to join us. I hope you enjoyed this webinar. And now I believe Dennis Bruce has a message for you. Dennis, are you there?
I am. Can you hear me, everyone?
Yes, we can.
Okay, great. So first of all, thanks, Alex. Great stuff as always. Let's get right into the questions. I know we're running a little bit over here. So Mr. Calvo has sent a question in, Alex. He says, how complex is it to leverage reserve? We're going to change reserve for spot, okay? How complex is it to leverage spot instances, and what considerations need to be addressed? There's also another part to that question.
Well, it's difficult in the sense that it forces you to think about your applications differently, right? So so the first assumption that your applications will always be running is taken away by using Spot. The reason being that AWS will reclaim its Spot instances and stop them, right? So you need to be prepared to handle those interruptions. Now you get a 2-minute window where you can where you can do that kind of work, right? So you can take care of saving the state of your workload, if you will, and spinning up additional servers if you need to. And I mean, doing that has at the beginning was more complex than today, and luckily AWS has made it easier over time to use Spot instances. And so and a great thing to note is that you don't have to, it's not a matter of Spot or on demand. You can use both, right? So there's something called EC2 Fleet. For example, in the case of EC2 Fleet allows you to have a fleet of AWS instances that are either on demand or on Spot, and you can provision a baseline capacity that's on demand, so that you avoid any potential outages, and you ensure that you have a certain base performance, and then anything that you spin up on top of that can be Spot instances. And like I said, in the past, doing that required a lot of glue code, right, and automating a lot of stuff by yourselves. But now you can use EC2 Fleet to do just that, and it's really easy to do that. But at any rate, a key consideration is, can my workload be stopped at any time, right? So if the answer is no, then I'm sorry, you can't go with Spot instances. But if the answer is yes, and the answer will be yes for a lot of workload types, such as stateless web services, for example, then by all means go ahead and experiment with Spot. It's not that hard.
Yeah, okay, Alex. I think you actually answered the second part of that question right there at the end, where Ignacio asks, are there any cases in which leveraging Spot instances is recommended easier to implement, or cases in which this might not be a good option or not an option at all? So I guess you've answered that question also.
Right.
There at the end. So, okay, good. How about Laura? Let's go to Laura's question. So Laura asks, why should I take the 1 hour free assessment from you guys? Okay, so that's, I like that question. That's a good question. So really, well, I mean, I could say something really easy, like it's free. I mean, that's one thing. But you know, I think that some value can be extracted from the free assessment, whether you have something that's minor, major. One of our architects will be working with you and your IT team during the consultation. We'll just build a quick checklist for you. Say, recommendations on what you can do, how you can do it, and then it's up to you how you want to implement. If you need us to help you, we'll help you. If you want to do it yourself, you can do it yourself or with somebody else. And there's no commitment. There's no conditions. You're free to do as you wish, but I think that there's a great deal of upside and very little downside on that. If you have anything else to add on that, Alex, I think that probably answers that one.
Right. Well, I mean, we are experienced in managing AWS workloads across several industries, and we always help our customers manage their workloads in a cost-efficient way. So sometimes we help them see why and where they're overspending if they are already in the cloud by the time they get to us. And sometimes we help them in their cloud journey. We help them adopt the cloud in a cost-efficient way. As we've seen, there's something called the AWS well-architected framework, and cost optimization is only one of the 5 pillars of the framework. So we also take into account the other 4 pillars when we build our solutions, when we provide our services to our customers. So we bring all that experience to the table, and you can take advantage of that in 1 hour, and hopefully we can answer your questions. And if there's some other way we can help you, we can work it out during that 1 hour assessment.
Great, thanks. Okay, question from Alfred. Do you analyze different technologies other than EC2, like AWS Lambda? I suppose, Alfred, you mean that within the assessment, but we'll assume that. That's correct. Okay, I'll let Alfred clarify. Yeah. So during the assessment, will you be looking at, beyond EC2, Lambda, maybe other services as well, Alex? How would you answer that?
Yeah, so I think Alfred just clarified that he meant in cost savings terms. So yeah, definitely. So Lambda, the Lambda pricing model is based on the number of executions, the allocated memory, and the execution time. Basically, those are the 3 variables. So as long as there are variables that you can optimize in order to reduce your costs, that's something that we'll be looking into. And Lambda is no exception, right? So we do take a look at Lambda functions performance and try to optimize them. So if they run for a long time, they might be incurring unnecessary costs. So we analyze Lambdas and make sure that they are allocating just the resources they need, and that they finish the execution within the shortest time frame possible to allow you to save more money, right? Yeah. So definitely, yeah, we do take a look at Lambda as well as other AWS services.
Great, thanks, Alex. Okay, so we've come to the top of the hour now, so thanks everyone for staying in there with us. Hopefully this session's been useful for you. We would like to remind you, for those of you who are with us, that there is an offer. If you look down towards the bottom of your screen, you will see the offers tab. And if you are interested in that free consultation, we strongly urge you to just take a few seconds, fill out the information that is needed for that, and we will get you scheduled as part of that form fill, and we'll get that, hopefully get your problems addressed or the recommendations to you as soon as possible. And once again, we'd like to thank you on behalf of Alex Cuadrado and Jorge Atala, Chief of Engineering, and the rest of the 3XM crew. We'd like to thank you very much for joining us today and look forward to seeing you again in the future. Again, don't forget to schedule a free consultation, and look forward to talking to you soon.
Thanks, everyone.